So this is a question from GATE 2011 from Chemical Engineering, question number 35. The particle size distributions of the feed and the collected solids sampled for the same duration for a gas cyclone are given below. What is the collection efficiency in percentage of the gas cyclone? And the four options given are option A 31, option B 60, option C 65 and option D 69. So this is a question from cyclone separator part in mechanical operations, and the NPTEL lectures can be found in Unit 2, Lecture 7, Effectiveness of Screen Mechanical Operations by Professor Shavina Khanam, Department of Chemical Engineering, IIT Roorkee. So here they have given us 6 different ranges of particles. 1 is to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25 and 25 to 30. And they have given us the feed of the particles in these size ranges as 2, 3, 5, 6, 3 and 1 respectively. They have also given the weight of the collected solids in this size range as 0.1, 0.7, 3.6, 5.5, 2.9 and 1. And using this table of data, we need to find the collection efficiency or overall collection efficiency of the gas cyclone in percentage. So we have defined that the collection efficiency of a gas cyclone, which is represented as eta, is equal to weight of the solids collected by weight of the feed. And if we need it in percentage, this will be into 100. Now what we have to do is we have to apply this collection efficiency formula for each of these different size ranges separately. So let us take the size range as range 1. This let it be a range 2, 3, 4, 5 and 6. The collection efficiency in size range 1 will be eta 1, and that is equal to weight of the solids collected in this range. So weight of the solids collected in this range is 2 the weight of the collected solids in this size range is actually 0.1, and the weight of the feed will be 2. So the collection efficiency in the size range 1 will be eta 1, which is weight of the collected particles 0.1 by weight of the feed, which is 2. And this will be equal to 0.05. Now similarly, we can write efficiency in the size range 2 as 0.7 divided by 0.3. So that will be 0.7 divided by 3, and this will be equal to approximately 0.233. The efficiency in the size range 3 will be equal to 3.6 divided by 5. So 3.6 divided by 5, and that will be equal to 0.72. Efficiency in the range 4 will be 5.5 divided by 6. 5.5 divided by 6, and that will be equal to 0.917. Efficiency in the size range 5 will be 2.9 divided by 3. So 2.9 divided by 3, and that will be 0.967. And the efficiency in the size range 6 will be 1 by 1, and that will be equal to 1. So these are the individual efficiencies in the different size ranges given in this question. Size ranges 1, 2, 3, 4, 5 and 6. Now here we need to find the overall collection efficiency. So we can define the overall collection efficiency as eta overall is equal to eta 1 x1 plus eta 2 x2 plus etc. up to eta 6 x6, where x is the mass fraction in that size range. So here in this equation we have found the values for eta 1, eta 2 up to eta 6. Now we need to find the mass fraction of these particles from the size range 1 to 6, and the mass fraction x will be equal to weight of the particles in that size range by total weight of the feed. Now for example, in the size range 1, x1 will be weight of the particle in that size range, and that weight of that feed in the size range will be 2. So this will be 2 divided by total weight of this feed, and the total weight of the feed can be obtained as the sum of all these feeds in the different size ranges. So this will be equal to 2 plus 3 plus 5 plus 6 plus 3 plus 1, which will be 20 gram. So the mass fraction in the size range x1 will be 2 divided by 20, and this will be equal to 0.1. Similarly, we can find the mass fractions of these particles in the different size ranges. So x2 will be 3 by 20, that will be 0.15. x3 will be 5 divided by 20, and that will be 0.25. x4 will be 6 divided by 20, and that will be 0.3. x5 will be 3 divided by 20, and that will be 0.15. And x6 will be 1 divided by 20, and that is 0.05. Now we can also check this by taking the sum of all these mass fractions and seeing if this sum of mass fractions becomes 1. So here 0.1 plus 0.15 plus 0.25 plus 0.3 plus 0.15 plus 0.05 will be equal to 1. So the mass fractions that we have obtained here is right. Now all we have to do is substitute the etas and the mass fractions x in the overall equation for collection efficiency. So eta overall will be eta 1 x1 plus eta 2 x2 plus etc. up to eta 6 x6. So substituting this, we'll get 0.1 into 0.05 plus 0.15 into 0.233 plus 0.25 into 0.72 plus 0.3 into 0.917 plus 0.15 into 0.967 plus 0.05 into 1. And if we do this whole sum, we can get the eta overall as 0.69. And since we needed this overall efficiency eta overall in percentage, we can just multiply this by 100 and we can get the overall efficiency eta overall as 69%. So the right option here is option D, 69%.